I'm Mark Van Moer, and along with my colleague Dave Bach, we are visualization programmers in the Advanced Application Support Group here at NCSA. Visualization is a process where you take large amounts of numerical data and turn it into a form that people can grasp visually. Visualization tries to represent the data in a way that people can use their visual intuition to grasp what the data has inside of it.
The main way that people work with us for longer projects is through a TerraGrid ASTA request. People can also contact us through the consulting office or TerraGrid help, especially if it's something like a software installation or a troubleshooting of a problem. That's probably the best way to go. We also have on our own viz.ncsa.illinois.edu webpage a form that people can fill out if they're just curious about what we can do to start the dialogue.
First, we talk with the scientists, meet with the scientists, find out what their research is about, maybe go over what they're trying to find out in their simulation. Then we'll get the data from them. Usually we'll have to pre-process it into actually from the scientist's perspective, we're post-processing it into a form that we can use in our visualization packages, either commercial packages that we have, or we also have some custom visualization software here. The next step will be to just start creating some imagery from it, experimenting with different things like the overall view of where the camera should be in relation if it's a spatial data set, where the camera should be in relation to the data, things like colors, color mapping, lighting, graphics, things like that. And then really it's an iterative process, so we'll come up with some ideas, we'll go back to the scientist with the images that we have. The scientist will say, okay, this is nice, let's continue with this, or they'll come back to us and say, well, this isn't showing the physics, or this isn't really showing the effect that we're looking for. My workflow now is mostly, I try to use one of the packages like ParaView or Visit first, and then when I get annoyed with one of those, then I'll drop down and actually write some code, C++ or Python, and try and get stuff. But what I'm doing visually is just taking snapshots of different camera views of the data from different things. And there's kind of standard stuff, if you get a scalar, which is just a single value per each mesh point, there's certain things you can do with that. If you get a vector, which is, a three-dimensional entity at each mesh point, there's different things you can do with that. So it largely depends on the data. If the data set is small enough, I'll do it on my desktop, which is just a standard graphics workstation. Has an NVIDIA GPU in it. If it's a large data set, we can do stuff on a GPU cluster called Lincoln that I've done one or two things on experimentally with, and the time, I mean, it's amazing. A render that would take literally 8 hours on my desktop, you can do in about 10-15 minutes on Lincoln. I mean, it's pretty amazing. There's a set of related projects I've been doing with Dr. Arif Masood that are related to his numerical mesh computations, but they're also all, from a physics standpoint, they all have to do with fluids. Different fluid effects of fluids moving around aircraft, fluids moving around cylinders, fluids with different properties. Fluids, from a visual aesthetic standpoint, are very interesting to look at. You always have interesting, whirls and different liquid effects that you can do with fluids. So those are always fun to work with.
The University of Illinois' National Center for Supercomputing Applications provides powerful computers and expert support that help thousands of scientists and engineers across the country better understand our world. With the computing power available at NCSA, researchers create computer simulations with real-world social and business impact. NCSA is supported by the State of Illinois, the University of Illinois, the National Science Foundation, and other federal agencies.